Welcome to Forces 101.
So we're going to talk about dynamics, which is where an object moves, and we primarily use the formula of sum of all forces equals mass times acceleration. So with dynamics, we have Newton's laws. So the first one is a particle will remain at rest or continue with its motion unless it's been acted upon by an outside force. So what this means is if we have a ball at rest and then we have another ball coming in to hit this ball, then this ball will move in return. So it's logical. So the second law would be the force on an object is equal to its mass multiplied by its acceleration. So what this means is that it's the formula that I wrote at the beginning. The sum of all forces equals mass times acceleration, mass being in kilograms and acceleration being meters per second, and force being in newtons. So this makes sense because if you have an object with a larger mass, so say you have a huge box and you're trying to move it, it's going to take a large thing of acceleration to move this thing that has a huge mass, and vice versa. So if you have something that is smaller, say like a little bouncy ball, it doesn't take much to move it. It doesn't take a lot of acceleration to move it, so you have a little a. And then lastly, we have the third law, which is every action has an equal and opposite reaction. So an example of this would be if you were to push it on a wall, it's going to push back. There's you're pushing on the wall. And this would be an example of force normal, actually, because you have a surface, and if you have a surface, it pushes back. So this would be, force normal is a good example of Newton's third law. So when we talked about Newton's third law, I mentioned normal force. So to go into more depth about that, normal force is essentially whenever there's a surface. So an example would be the wall, like I did in Newton's third law, but also an object resting on a table. So here's a table. Really bad, I know. But you have a book right here resting. So you're going to have force of the gravity pushing down, which keeps the book grounded, but then you also have force normal pushing up, or else the book would just fall through the table, and that wouldn't be very helpful. there's of course some sort of resistance, and we call that resistance frictional force. So say you have an object on a plane, so a box, and you have to move it, and you're pushing it in that direction, and you have force gravity going this way, force normal this way. You're going to have frictional force that way. Here's the force that you're pulling it by, right here. Typically to find frictional force, it equals mu times force normal. And mu is just some sort of constant that they give you in the problem. And force normal you can solve by doing force gravity and force normal set equal to each other, since they both have to cancel out, and because your object's not falling through your surface or anything like that.
How about that? How about that? Catch me outside. How about that? Catch me outside. How about that? Catch me outside. How about that? How about that? Catch me outside. Catch me outside. Catch me outside. How about that? Catch me outside. Catch me outside. Catch me outside. How about that?
The hoes are laughing.
Yup.
The hoes are laughing.
Yup.
Hoes are laughing. So the audience are a bunch of hoes.
Yup.
What does that mean?
What I just said.
What does that mean?
What I just said.
What does that mean? What does that mean?
What I just said.
Sit
Catch me
down.
outside. How about that? How about that? How about that? Catch me outside. How about that? How about that? Catch me outside. How about that? How about that? How about that? Catch me outside. How about that? How about that? How about that? Catch me outside. How about that?
Okay, what is the tension of the string? This is the force of tension, force of gravity, which is mg. Sum of the forces equals 0. Tension equals mg. That's 10 times 10. 100 newtons. Good. Next is a free body diagram. Force of tension, force of friction, force of gravity, and normal force. Now we split up the force of gravity into xy's. Force of gravity y and g. 60 degrees, and you got that 60 from here equals 50. And then the force of gravity x equals mg minus 60, which equals 87. So you have this way, your force of gravity, and this way, force of gravity, 50 and 87. The frictional force is equal to force plus force of gravity x equals the force of tension. 100 equals 87 plus the force of friction. The force of friction equals 13 newtons. So after the string is cut and the left-hand box slides down the inclined plane, we have our free body diagram. This is 87 minus 7.5, which equals 79.5 newtons down. So now we have to do a sort of kinematic with this. And so we have 79.5 equals 10 times A. So A equals 7.95 here. Our distance is 2, and V1 is 0. We're solving for V2. So we're going to use V2 squared equals V1 squared plus 2AD. V1 2 times 7.95 times 2, which gives us V2 squared 31.8. There we go. V2 5.64 meters per second. The first type of force we're going to talk about is statics. Statics are forces that hold things still at a constant velocity. When they're holding things still, the forces cancel out. One force is the force of gravity. There's the force of gravity directed towards the center of the Earth, or the force of gravity between two objects. The formula for the force of gravity towards the center of the Earth is F of g equals mg. The next formula is the formula for gravity between two objects with mass. It's g m1 times m2 all over d squared. Free body diagrams show 2D representations of the forces acting on an object. You should show your forces using vectors. Newton's law states that the sum of the forces equals 0, which is static forces, where all forces acting on the object cancel out, and there is no movement. The next type of force is normal force. Normal force is a matching force, and it is also always 90 degrees to the surface. F of n equals F of g.
The formula for centripetal force is mv squared over r. Any motion in a curved path represents accelerated motion and acquires the force directed towards the center of a curvature of the path. This force is called the centripetal force, which means center-seeking force. The force has the magnitude. Swinging a mass on a string requires string tension, and the mass will travel off in a tangential straight line if the string breaks. The centripetal acceleration can be derived for the case of circular motion, since the curved path at any point can be extended to a circle. V squared over r is the centripetal acceleration. We should discuss how the object came to be moving along the circular path in the first place. Newton's law, his first law, tells us that an object will continue moving along a straight path unless acted on by an external force. The external force here is the centripetal force. It is important to understand that centripetal force is not a fundamental force, but just a label given to the net force which causes an object to move in a circular path. The tension force in the string of a swinging tethered ball and the gravitational force keeping a satellite in orbit are both examples of centripetal forces. Multiple individual forces can even be involved as long as they add up by vector addition to give a net force towards the center of the circular path. Starting with Newton's second law, A equals F over m, and then equating this to the centripetal acceleration, V squared over r equals F over m, we can show that the centripetal force, Fc, has magnitude, Fc equals mv squared over r, and is always directed towards the center of this circular path. Equivalently, if W is the angular velocity, then because V equals RW, Fc equals mRW squared. Thank you for listening to Centripetal Forces.
Hey, do you want to see something cool? I can make this olive go into this glass without touching it.
How?
Physics.
Wow, centrifugal force.
Actually, it's centripetal force, which is an
Thank you for listening, and I hope you get a 5 on that physics AP test. Woo! Go Forces!